All right, so this time I want to talk about point-slope form, which is another form of the equation of a line. All of these are linear functions. They're all really just different ways of writing the same thing. So just as a refresher, last time we had this thing, which is not point-slope form. It's y equals m, which I did in pink before, so I'll keep with that, x, and then plus b. And b we said was our y-intercept. And we said that m, as I said before, is our slope. So we called this the slope-intercept form because it's the form with the slope and the intercept in it, the y-intercept. This one is point-slope form, so we're going to keep slope. And instead of having an intercept, we're going to have something that's called a point. And you know what that is, right? That's a coordinate. So what we're going to do here is instead of having an intercept from the graph and the slope from the graph to make the equation, we can take any point they give us and a slope and put it together in an equation, which is really, really useful. So the form of this thing is going to look like this. It's going to look very similar to slope-intercept. It's going to start out the same, y equals. So y is on its own for this form as well. Then we have m, which again should look very familiar. They both start out very similarly. And then this thing happens, and it makes it look kind of awful, but it's really not. I promise, I promise, I promise. The x is inside this parenthesis, right? This quantity that we're quantifying here. And then in the inside with it is this thing. It's minus, and it's going to be an h, which I'm going to do in, I don't know, how about orange? Minus h. Looks awful, plus k, which I'm going to do in, I don't know, let's try the minty green. Let's see if that works out. We'll call it k. Now, the reason I use minty green here is because this variable right here, k, is very similar to b. It's almost a y-intercept. It's very, very close. And this h here is kind of similar to red because it has to do with x. It has to do with our left and rightness, which is what x is, right? And y is our up and down, our y-intercept. So I try to keep those color-coded as much as possible. So the idea behind this is that m is the slope, and we know what that is, right? The rise over the run, and I will write that like this real quick. Rise over run. And we talked about that formula for it last time. This guy right here, y sub 2 minus y1 over x sub 2 minus x sub 1. That's the difference in the vertical value, so how far we went up, versus the difference in the horizontal values, how far we went over. So where we were, where we ended up vertically, where we were horizontally, where we ended up horizontally. And that's going to be the slope. These guys right here, because y and x are just our coordinates, all the coordinates that fit on this line, h and k are a coordinate, a point, if you will, themselves. So the coordinate, or the point that they give you in these problems, whatever it is, the x value of that coordinate is going to be the h value here, and the y value is going to be the value that you plug in here. So this really helps with an example. I'll start out like this. So maybe they give you a point, and they say 2, 3, and they tell you a slope of, I don't know, how about minus 3 over 5. So they say they want a line. Oh, hold on one second. Hi, what's up?
Nothing, I just heard noise. I'm like, what is that?
That's me. I'm recording a video for tomorrow, so say hi.
Oh, super cool. Hi.
Yeah.
Sorry to interrupt then. You were in the middle of recording.
Yes, no worries though.
Sorry.
No worries, no worries. Have a good night. All right, so we've got a point right here, and we've got a slope right there. So what we're going to do is we're going to take these two things and plug them into our point-slope formula, and it's going to pop out an equation that represents a line that goes through this point and uses this slope right here. So the idea is going to be we're going to have y equals m is going to be this guy, right? We just literally plug it in. Our slope here, they told us, was negative 3 over 5. And then x, just keep that. And then we have minus whatever h is. Well, h in this case is going to be 2, because the x value of the coordinate they give us is h. And the y value, which I did in kind of a off color here, I'll try to keep it sort of similar, not even close. The k value is here, this 3 right here. So that's going to go on the outside. So the idea is that this is going to be plus 3 on the outside. And it's going to be minus 2 on the inside. So the key for point slope form is to remember that the h and k go here, and that the h has a minus next to it. So if that's a 2, we're going to write a minus 2 here. If it was a minus 2, we'd write a plus 2, because remember, negative just means switch the sign. So when we have that negative in our formula, it says do whatever h is, but change the sign. The plus means do whatever k is and keep the sign. So k was 3, so we kept the sign. It's plus 3. And 2 was positive, so it becomes negative. And that's it. That's the equation of this line, a line that goes through 2, 3, and has a slope of negative 3/5. So that's kind of cool. If we got something like this, we could easily graph it. If I make myself a little coordinate plane, we can plot 2, 3 right here. 1, 2, 1, 2, 3. That's our coordinate 2, 3 from above. And now you got to be careful when you're reading this. Remember, that minus is put in there by the formula right there. So we don't include that when we write the coordinate, right? The original coordinate was 2, 3, not minus 2, 3. And so we take that, and then we use our slope, negative 3 over 5, to find our next coordinate. And I'll do that in red and green in pen. So we go down 3. That's what that minus 3 means. So down 3. And that's kind of nice. It lets us hit the x-axis. And then from there, we go over 5. So 5 to the right. 1, 2, 3, 4, 5. So this right here was 5 to the right, a positive 5. And this was down 3, a minus 3. And that's where our next point's going to be. So 1, 2, 3, 4, 5 right here. And there's our 2 points, and we connect them to make a line. So not as easy, I think, as using slope-intercept, but pretty darn close when it comes to graphing. What's nice about this form is that it's so darn similar to slope-intercept form, right? It has a slope, and it has something that's kind of like a y-intercept. It's how much we go up, that k value there, and I'll talk about that later. And it has this h in the inside, which is kind of annoying. It's 2 different things to worry about, but it's really nice because it lets you take a point and just plug it in, and take a slope and just plug it in. You got yourself an equation. If for some reason they gave you a slope and a point, and they said, hey, I want you to write this in slope-intercept form, so they want you to write it in this form right here. First, you write it in this form, and it's really easy to convert it. So what I'm going to do next is I'm going to take this equation right here, and I'm going to convert it to slope-intercept. So right now, it's in point-slope, and I'm going to convert it into slope-intercept after I adjust all this stuff. So here we go. There's the equation. We're going to keep the y the same, because slope-intercept and point-slope both have y on its own. And it's going to be equal to this slope times into here. So we're going to distribute this. So this negative 3/5 is going to get times into the x, and it's going to get times into the minus 2. So we're distributing that using the distributive property. So what we get is negative 3 over 5 x. And the reason we get that is because negative 3/5 times 1x is negative 3/5 x. Then we do this. So a negative times a negative is a positive. So it's going to be positive whatever it is. That's kind of nice to know. And then we have 3 times 2, which is 6. And then it's divided by 5. Well, 6 divided by 5 is just 6/5. And then we have this plus 3 that's kind of sticking along here. So as you can see, we're really close to slope-intercept form. We have our slope next to our x. And then this, when we combine it, is going to become our y-intercept. So that's kind of useful. So when we add 3 to 6/5, we need common denominators. So we're going to have everything the same as before. Everything the same. Except 6/5 and the 3, that 3 right there, are going to get combined. So how many fifths are in 3 is what we should be asking. Well, there's 5/5. 5, ugh, my hands are gross. 5/5 in 1, right? 5 over 5. But it does give us the slope-intercept form. Our slope is here. This is m, our slope. Our rise is -3, and our run is 5. Let me erase that a little bit. And this guy right here, even though I did it in the wrong color, is our y-intercept. So it's easy to convert from point-slope form, this guy right here, into slope-intercept. Slope-intercept. In all honesty, I think this one's actually a little more useful, but this is more concise. And now often we won't get a fraction for this guy here. It was just some of the numbers that I picked didn't work out too nicely, but this is the thing. So that's slope-intercept into, or sorry, point-slope form into slope-intercept form. We've graphed point-slope using 2 and 3 as a point, and then using our slope to find the next one. Again, we use our slope from the point we just graphed. That's really important. We did that before with slope-intercept. We did it with this one too. The point you just graphed, 2, 3, and then use the slope to find your next guy. So I'm going to do one example, and then we'll put it away. So what if they want you to write this in point-slope form? They give you 2 coordinates instead of a point and a slope. They give you 2 coordinates, maybe 2, 5, and maybe -3, -4. And they say, I want to find the equation of line that goes through both of these points, and I want you to write that in point-slope form. Well, just to be clear, point-slope form is y equals, it's really similar to slope-intercept. It's going to have a slope because it's point-slope, but then it needs a place to put in a point. And the way we put that in is we have x minus h, and h is the x coordinate of the point we're choosing. Did that in orange last time. Closed quantity. And then we have plus k, which is the y value of the coordinate of our choosing. So we have 2 coordinates to choose from, right? So we can make h and k 2 and 5, or we can make h and k -3 and -4. It's our choice. Now in this case, I'm going to choose 2 and 5 because I'd rather work with positives than negatives. That's just the way I prefer to work. I know most people prefer to work with positive people, so do I. So if we want to write this in slope-intercept form, well, we can do that pretty easily, at least most of it. We don't know what m is yet, but we can find that. We have a formula for slope. And we just plug in the point of our choosing. So if I'm minusing h, and I'm choosing this coordinate right here, our h is 2 because that's the x value of our coordinate. And our not matching color, k is 5. So h and k. So when I go to plug in h, I do minus whatever h is. So I'm going to minus 2. I close that quantity off. That's really important to close those parentheses. And then on the outside, I have my k value, which is 5. So I chose these 2 points. Now, you could have chosen -3 and -4. I'll show you what that looks like quick. It's going to be the same thing here. Y equals m, which we don't know yet. We have to go find that. We're not finished until we plug in m. And then it's going to be x minus whatever k is, or h is. And if we choose this to be our h and this to be our k, then h in this case is -3. So minus a -3. Well, minus means change the sign. So -3 is going to be a +3. So this becomes +3. And then over here, we're going to add -4. Well, add just means keep the same sign, right? So we're going to turn that guy into a minus. So it's going to be -4 on the outside. So both of these equations represent the same line. Both of these lines are supposed to go through 2, 5, and -3, 4, and they do. One says it explicitly that it goes through 2, 5, and the other says it goes through explicitly -3, -4. Either will work. I'm going to focus on this guy right here from now on because, again, I like those numbers better. And I'm going to take him and I'm going to find out what m is because I still need to plug in this guy to my formula before I'm complete. So in order to find m, we know we have a formula. M, our slope, is going to be the distance between the y's, the rise, right, how far we went up, over the distance of the x's, the run. So again, this is our run, and this is our rise. The rise is how far we went up, so of course it has to deal with y values, because y's are all about up and down. And the run is the x values, because run is all about left and right, and so is x's. How far we went is distance, distance is subtraction. So there's our formula. So we need 2 points, and we have 2 points. And when we compare those 2 points here, the distance between their y's and x values, we get the slope. So I'm going to write those points down here so I can see them in view of my slope formula. Our points from the problem were 2, 5, and -3, -4. And I'm going to call them as I see them. I'm going to call this point number 1, and this coordinate number 2. And so that means that this is x1, x number 1, and that's x number 2. And that's y number 1, and that's y number 2. So when we plug into our formula, it's going to be the y's subtracted, and the x value is subtracted. We start out with y number 2, and y number 2 in this case is -4. Again, order matters, so make sure you're consistent. So that's -4, and it says minus y1, so we're going to subtract y1, which is 5. Then on the bottom, we subtract x2. Remember, we did y2 first, so we need to do x2 first over here. So x2 is -3, and x1 is 2. When we subtract these, we can simplify and get one nice slope. -4 minus 5 is -9, -9. And -3 minus 2 is -5. And now you'll remember that a negative divided by a negative is a positive. So this is going to be a positive 9 once we simplify it. 9 doesn't divide by 5 evenly, so we just leave it as 9/5. And it's going to be a positive 9/5, although either slope is acceptable. Both of these could be a slope. Again, I prefer to work with positive people and positive numbers. So I'm going to use this guy as my slope. And when I write the equation out fully, I'm going to use the equation up here, this guy right here, but I'm going to write in a slope of 9/5. So I get y equals 9/5, our newly found slope. Again, you could write 9 or -9 over -5 if you wanted, but I'm going to keep it as positive as possible. And then inside the quantity, we have x, and it's -2, because the coordinate we chose from the beginning, this guy right here, is a 2 right there. So it's minus whatever this guy is, it's -2. And then it's plus whatever this guy is, which in this case is +5. So there is the final version of our equation. It's an equation that goes through 2, 5, and it also goes through -3, -4. It has a slope of 9/5, and here's what's going on here. So if we were to graph this, you would find this works. I will graph it really quickly, and then I'll close this guy on down. So graphing that equation right there would look something like this. Let's see, what do we have? 2, 5, and up 9 over 5. So I'll do my line really low. Something like that. Something like that. Let's see the equation. Get a little bit lower, a little bit lower. It's going to cover up my graph a little bit. So 2, 5 is the point we need to graph. Remember, it's not -2, 5. It's 2, 5, because that guy we made negative after the fact. So if I graph 2, 5, I go here. 1, 2, and then up 5. 1, 2, 3, 4, 5. So there's our point 2, 5. That's this guy right here. From here and there. Then we use 9 over 5 to find our next point. So if I go up 9, it's a lot to go up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm kind of chasing myself away here. And then it says over 5. 1, 2, 3, 4, 5, over 5. My next point should be right there. And again, I used my slope after plotting this point. I plotted the point and went up 9 and over 5 from there to find my next one. Because slope is the separation between points on your line. So you have to start out with a point that you know, and then use that slope to find the next point. And then we draw our line. I'm going to draw this really carefully because I wanted to show you something. As carefully as I can. So there's my line. And remember, the line that we made, this equation, was supposed to go through 2, 5, which we made sure we plugged it in. But it also should go through -3, -4. And if you check down here on our graph, -3 is negative 1, 2, 3. And if you check down here, it's about 1, 2, 3, 4 to right there. And that's where our line would go through. So it does, in fact, go through negative 3, negative 4. It's just way off down here at the bottom. So depending, it doesn't matter, it doesn't matter which point you choose to put in for here. You could put 2, 5 in this case, or you could go back here and do what I did, putting in negative 3, negative 4. Either or is going to get you the same line, and it's going to get you a line that goes through both of those points. Last thing, real quick, I know I said that before. I want to take these two lines that I drew, or I came up with, these two equations, and I want to show you they're the exact same thing. So even though they look different, should be 9/5. Let's do this, 9 over 5. We've got x on the inside, minus 2 in this case, and plus 5 in this one. So there's the one we graphed. And I'm going to show you that it's the exact same thing as the other one, which is y equals 9 over 5, same slope, but different point plugged in. We had plus and minus here. We ended up with a minus 4 and a plus 3, because originally our point was minus 3, minus 4. I'm going to show you they're the exact same thing. When I distribute this value right here, when I take 9/5 and I distribute it here and here, and I take 9/5 and I distribute it here and here, we're going to end up getting the exact same equation. So the first one, when I distribute 9/5, ends up looking like this. This guy becomes this. Y equals 9 over 5 x. 9 over 5 times minus 2, well, that's going to be a negative number. So it's going to be minus. 9 times 2 is 18. So I'm going to do that. And then I divide it by 5. 18 divided by 5 is that. And then I have a plus 5 left over from before. How many fifths are in 5? 25 fifths are in 5. I'm subtracting 18. So 25 fifths in 5, 18 fifths is what I'm subtracting from it. Right? Negative 18 fifths plus 25 fives, 25 fifths. And we're going to get 7 fifths over here, positive. So when we simplify this down into slope-intercept form, we get a slope of, you guessed it, 9/5, and a y-intercept of 7 over 5. Now when I do this up here, same idea, I should get the same thing, because they are the same line, I said. So I should get the same slope-intercept form. So I'm going to do that down here. And I get y equals, again, 9 over 5 for our slope. And then x, because 9 over 5 times x is going to be 9/5 x. And 9 over 5 times 3, well, that's 3 times 9 is 27. And then we divide it by 5. So it's plus 27 over 5. And then we have that minus 4 still sticking off there. So when we try to combine these, we have to think, how many fifths are in 4? Well, 20 fifths are in 4. If we have 27 fifths and we're subtracting 20 fifths, we get 7 fifths, same as the other guy. So when we write this all out, we get y equals, and I'll try to squeeze it in over here on the side of my graph, 9/5 x, and that's going to be a plus 7/5. Again, the way I got that 7/5 right there is that I had negative 20/5 here. That's what 4 is equal to, right? We had 5/5 in 1, we had 10/5 in 2, we had 50/5 in 3, so we have 20/5 in 4. So that's 20/5. 27/5 minus 20/5 is 7/5. And notice they are the exact same equation. Same y-intercept, same slope. And if you check on our graph, 7/5 is the y-intercept, 7/5 is a little more than 1, and a little more than 1 looks like that's our y-intercept. 9 over 5 up 9 over 5 is the slope that we had. So they are the exact same thing.